Hi everyone. So in this video, I would discuss three questions from the SAT Practice Exam 1, Section 3 without calculators. So these three questions are particularly chose because sometimes students may be like thrown off by the questions itself. It seems a little bit tricky, but I don't say that they're hard, but it's you just need to have confidence that you can solve this, but to have that confidence some tricks are in sat math, right? Okay, so how do we solve this? So we have if a over b equals 2, what is the value of 4a over b? So sometimes I've seen students, okay, they panic over, okay, what's a, what's b, how do I find this uh, without knowing A and B? The answer is you don't need to actually know what A and B is. You just need to know what A, I mean, some information would be enough to solve this, some kind of information, which is this information here. A over B equals 2. Okay, so let's see how we can solve this. The idea is that, so you want to find the value of 4b over a, right? If you write it like this. So do you see a relationship between b over a and a over b? So you have a over b equals to 2. Do you see any relationship between these two, right? Oh, sorry, there should have been 2. So the thing is that if you look closely, this is just, so one important um, fact in algebra is that if you have, so b over a is the same thing as 1 over a over b, right? So it's just b over a is 1 over a over b. For example, if you have 2 over 3, this is the same thing as 1 over 3 over 2, right? So this is the same thing as that. All right, so using that fact, you have 4 times 1 over a over b, right? So we know that a over b is 2, 4 is 1 over 2, which is 2, right? So this is your answer. So C is your answer. Also, okay, so this is a nice, method of solving this. This is like using some fact in algebra, right? Using algebra fact, right? So this is not hard, but if you're not familiar with these kinds of questions, let me show you another way. So you know that a equals 2b, right? I'm sorry, let me just write it like this. A equals b, a or b equals 2, right? So what do you do? So let's say if you multiply both sides by b, so you multiply both sides by b, which you have b times a over b plus, sorry, equals 2 times b, right? Okay, so the b on the left hand side cancels out, right? And then you get a equals 2b. Okay, so this is what you get. All right, so let's go back to the equation we want to solve. We have 4b over a, and we know that a is equal to 2b, right? All right, let's go ahead and substitute that here. So this is called the substitution method. 4b over 2 over a, which is 2b itself. Okay, all right, so when we write this, so you know that when you have these types of fractions with the same number multiplying together, you can just cancel this out. Okay, so we end up with having 4 over 2, which is just 2. Okay, so this is using substitution. So in SAT math, you may be given some relationship between two variables or three variables, and then you are asked to find another another expression using that, right? Maybe involving two or three other variables. So it's not that rare to find things like this. Okay, so we will see another question in this sense. Let's go back and see that. Okay, so this is the 14th question. Again, it's a multiple choice question from the same section. Okay, so right, so you have 2x minus y equals to 12, and what is the value of 8x over 2y? Okay, so let's look at this formula, 8x over 2y, right? Okay, so 8. So you need to be a little bit, really familiar with these numbers. So you have a 2 and you have an 8. So what reminds you about 2 and 8? So the fact that is that 8 is equal to 2 times 2 times 2, right? All right. So which is 8 equals 2 to the 3, right? Okay, let's use that here. 2 to the 3 x. So you have 2 to the 3 and you take the x power of that and 2 to the y. Okay. So now let's simplify this. So you see that 2 to the 3, you have 2 to the 3 and then you take the x power of that. Okay, so when you have some uh, power of that, like 2 to the 3 to the x, you can actually multiply 3 and x and put them together. 3x over 2y. So we are using properties of exponents. So let me write the properties of exponents that we are using of exponents. Just doing a quick revision of the properties of exponents that we are using. Okay, so let's say you have a to the b, and then you need to take the power of c. So this is basically multiply b by c. So a times bc. So let me write an example. Let's say you have 2 to the 5. Let's say, no, let's not take 2 itself, because why not choose another number? Let's say we have 5 to the 3, and then you want to take the power of 4, right? Okay, so what you have is you multiply 3 by 4, you get 5 to the 12, right? 3 times 4 is 12. Okay, so another example, 5 to the 6, let me write it over here, 5 to the 6 to the power 1 half. Okay, so what happens when you multiply 6 by 1 half? You get 3, right? You basically multiply 6 by 1 half is the same thing as dividing 6 by 2. Okay, so we have 5 to the 3. So you can even have fractions in this, not just integers. Okay, all right, so here's another property of exponents. So you see that when you have 2 to the 3x and y below down, you can basically write it as 2 to the 3x minus y. So you bring this y that is on the bottom to the top, and it becomes all of a sudden negative. So this is what you have, 2 to the power. So you take 2. So what you do is you find 3x minus y, or let me just write it really nice so that you get clear idea here. 3x, take 3x minus y to the power 3. That's what you actually have. Okay, so what is 3x minus y? That is 12, isn't it? So that's what they have given here. So see how everything matches up, right? So 2, sorry, let me write it down below here, 2, and then you put 12 here. So that's 12, 2 to the 12. Okay, so that means your answer is A here. Okay, right. So let me go through this property that I used here. If you need to have a to the b over a to the c, that becomes ab minus c. So whatever in power you have on the denominator, it comes up and becomes a negative, right? I hope you have seen this earlier. Let me give you an example. We just scroll down a bit. So let's see, let's say you have 3 to the 5 over 3 to the 2, right? Okay, so this becomes 3 5 minus 3. sorry 2, which is 5 minus 2 is 3, so this is just 3 to the 3. Okay, and let's do another example. Let's say you have 7 to the 4 over 7 to the 10. So this becomes 7, 4 minus 10, which is 4 minus 10 is negative 6, right? 7 to the negative 6. So even though you have a larger number in the denominator, it just becomes a negative. You just bring it up negative. So that's how it works. Okay, right. So now just back to see what the key takeaways here. So one thing is that you need to, so when you have something like this, you need to be a little bit, really good with your eye to not seeing things like this, right? So you have 8 and 2. Okay, what's the relation? Okay, relationship. Okay, 8 is obviously 2 to the 3. So you plug that in. Okay, because you see, as you see that, as soon as you see this thing here, and as you see, and if you need to, so it comes to your mind that there's something to do with these exponents, right? But we can't actually do anything if the two numbers are different, 8 and 2. Okay, so we need to somehow convert 8 into a 2. How do we do that? 2 to the 3, right? That's what you do, and then the rest of this follows from the properties of exponents. So just to make a case here, I'll just write some important powers of numbers so that things are, you're familiar with these numbers. Let me write them. So 2 to the 2 is 8, 2 to the, sorry, oh, 2 to the 2 is 4, 2 to the 3 is 8, 2 to the 4 is 16, and 2 to the 5 is 32, 2 to the 6 is 64. Yes, and then I just write this, 2 to the 7 is 120. Just to, like, I mean, I won't encourage you to memorize them. It's just train your eye to spot these numbers, these special numbers. Train your eye to spot these special numbers so they come handy during in the SAT exam. Okay, let's do with this with 3. 3 to the 2 is 9. 3 to the 3 is basically equal to 27. 3 to the 4 is equal to 81. Let's just do one more. 3 to the 5 is just 243, right? Just train your eye. I mean, even if you don't recall the exact number, I mean, when you see a problem with these numbers, it may come to your mind, okay, this should be it, or maybe if you get some, a small memory of these numbers, you may try to verify that you can just multiply by 3 and do something, then you get the. And if you're really keen on memorizing this, okay, go ahead. It won't hurt, but yeah, let's do some with, let's say, 4, right? 4 to the 2 is equal to 16. 4 to the 3 is equal to 64. 4 to the 4 is equal to um, this should be 256, right? Okay, right. So I will stop here. Well, you can actually do this small, a really fun thing to do when you're like, um, relaxing, maybe. I don't know if you like it, but you can just look at these numbers a little bit and just train your eye to spot these types of numbers in SAT. Okay, right. Okay, so let's move on to the next question. So this question is from the section 3, same thing, same section 3, but not an MCQ. It's a written question. So you see that a equals 5 square root 2, and then we have 2a equals square root of 2x, right? What is the value of x? So there's square roots, there's a, there's x, and all that. Okay, so what you need to find is, I mean, look at the final objective of this. Our final goal is to find the value of x, right? Okay, so x is inside a square root. So when you find some variable inside a square root, what do? Just get rid of the square root. So what do? You square both sides. just want to get rid of the square root so that I can have an x out. Okay, so 2a squared equals square root of 2x squared. So once you square this, you get, okay, so you can actually distribute powers when you have a multiplication, not an addition but a multiplication. Okay, so what happens here is 2 to the 2, you distribute the powers, a to the 2 equals, so what the square root cancels out with 2, right? Okay, so you get 2x. All right, we just write it a little bit nice. Okay, now what do we want? We want x, right? So we have, I'll just move the equation, I'll just flip the equation to have 2x equals, so 2 squared is 4a squared. Okay, now just divide both sides by 2. You have x equals 2a squared. Okay, good. So we have x equals 2a squared. Okay, now it seems really simpler, right? So we have a squared, we just plug a squared into this, right? We just substitute that here. So 2, 5 times square root of 2 to the 2. Okay, so what do we do now? Just as we have done earlier, let's distribute the power to the numbers inside. You have 2 outside, you get 5 squared and square root of 2 squared. So I'm writing each of these steps, every step, but if you are really familiar with this, you can just storm out directly without writing each of these steps. 2, and so this is like 5. So when you have multiplication, the brackets, the parenthesis is not that important, so you can just write it out like this. 5 to the 2 is 25, right? Okay, another important thing, 5 squared is equal to 25. All right, square root of 2 to the 2, that just becomes 2, right? Square root cancels out. Okay, so we remember that all this is equal to x. So the final value of x is equal to 2 times 25 is 50 times 2 is 2, which is 100. Okay, so this is what you get, 100, right? So okay, so let's go back to where we started out to count the key takeaways from this. So we have 2a equals square root of 2x, and so look at the final objective of this question, to find x, and x is inside a square root. First you get rid of the x square root, and you pretend that a is just a number, right? We know what a is, so just solve for x. So now this is the idea, is to solve for x. This is the same thing that you would do in a regular equation, right? You divide both sides by 2, and then you clean the expression out. Then you have x equals 2a squared, and then you substitute for a squared based on the number they have given, and then you calculate x, and then you get this x equal to 100. Beautiful, right? Okay, so I hope this was helpful to you. So see you in another video, right? Have a good day. Bye.